Graham's law of diffusion. Graham's law of diffusion. In this lesson, we are going to learn definition of diffusion, Graham's law of diffusion, and detailed mathematical expression. So let's get started. Definition of diffusion. Diffusion. Let us suppose this is perfume bottle. Here the lid is opened. Perfume is a highly volatile substance. Here, perfume gases with high concentration. When the lid is opened, then perfume molecules spread spontaneously. Perfume molecules move spontaneously in all directions, irrespective to the gravitational force. That is, here spontaneous spreading of gaseous molecules from the region of higher concentration to the region of lower concentration. Let us suppose this is a beaker with liquid water. Here, a drop of liquid blue. Here, molecules of blue, liquid blue, move spontaneously in all directions. Spontaneous movement of liquid substance in liquid medium. Spontaneous movement of gaseous substance in gaseous medium. Let us suppose another beaker with water. Here, solid pink color potassium permanganate. This is potassium permanganate. Potassium permanganate with pink color. Molecules of potassium permanganate move spontaneously, and as a result, after some time, the whole liquid becomes pink. Here, after some time, the whole liquid becomes blue. Here, after some time, the region around the perfume bottle becomes scented. That is, what is diffusion? The spontaneous movement or automatic spreading of molecules from the region of higher concentration to the region of lower concentration. The molecules, spontaneous movement of molecules from the region of higher concentration to the region of lower concentration. The spontaneous movement of the molecules from the region of higher concentration to the region of lower concentration in suitable medium is known as diffusion. the spontaneous spreading of molecules from the region of higher concentration to the region of lower concentration is known as diffusion. When a matter takes lesser time to diffuse, its rate of diffusion will be higher. Now, Graham's law of diffusion. Graham's law of diffusion. Rate of diffusion. Rate of diffusion is denoted by lowercase r. Graham states that rate of diffusion is inversely proportional to the square root of its density. Rate of diffusion, according to Graham's statement, rate of diffusion is inversely proportional to the square root of its density. Again, we know density is equal to mass by volume. Mass per unit volume is known as density. For two gases, we can write rate of diffusion is inversely proportional to the square root of its density. This is equation number 1. For the second gas, rate of diffusion is inversely proportional to the square root of its density. R1 and R2 rates of diffusions of two gases. This is equation number 2. Now, from equation 1 we can write rate of diffusion of the first gas is equal to proportionality constant 1 by square root of its density. For the second gas, proportionality constant 1 by square root of its density. Suppose this is equation number 3 and this is equation number 4. Now, equation 3 is divided by equation 4. Then we get R1 by R2 is equal to root over of d2 by d1. That is, rate of diffusion of any gas is inversely proportional to the density of the gas. Rate of diffusion is inversely proportional to the density of the gas. Suppose this is equation number 5. We know density is equal to mass by volume. This is molecular mass. For the first gas we can write M1 by V1, and for the second gas we can write M2 by V2. Now, putting the values of D1 and D2 in equation 5 we can write from equation 5, putting the values of D1 and D2, R1 by R2 is equal to root over of D2, that is M2 by V2 divided by D1, that is M1 by V1. We know molar volume of any gas is 22.4 liters at STP, that is molar volume of any gas is 22.4 liters. So it is considered V1 is equal to V2. Then from this equation we can write R1 by R2 is equal to root over of M2 by M1. This is another expression of Graham's law of diffusion, mathematical expression. That is Graham's law of diffusion. Rate of diffusion of any gas is inversely proportional to the square root of its density, or is inversely proportional to the molecular masses of the gases. Graham's law of diffusion. Thank you for watching.